We are given that the speed of the cyclist is s prime t equals to negative 3t squared plus 18t. We need to remember this, that the derivative of s at t is speed, the rate at which distance changes over time. So it's already the first derivative of distance. Ne? The first derivative of distance is speed. The second derivative of distance is acceleration, which means the derivative of speed is acceleration. All right, that is very important to know. Ne? S at t, let me just write it down here first before we start. S at t, this will be distance. Ne? S prime t will be speed. S prime t would be acceleration. Right, those are the most important things you need to know. The derivative of displacement is velocity. Sometimes distance we're gonna say displacement, speed we're gonna say velocity, but acceleration will just remain acceleration. Now 10.1, they want us to calculate the maximum speed the cyclist reached. And with this question, I need to be clear, and I won't rush it because many learners get confused here. To calculate the maximum speed, we need to set the acceleration to 0, and I'm going to explain why. Legend, here's the thing. When speed reaches a maximum, it stops increasing for a moment. That means the rate of change of speed is 0. And we said the rate of change at which speed is changing over a given time is acceleration. I'm going to repeat it. When speed reaches a maximum, it stops increasing for just a moment. That means the rate of change of speed, which is acceleration, is going to be 0. So to find the maximum speed, we always going to get the second derivative and equate it to 0, because if you are in maximum speed, it means you are no longer accelerating. Does make sense for a moment, right? That's why we're not setting speed itself 0, because speed being 0 means the cyclist stops, it's no longer moving. But maximum speed happens when acceleration is 0. I hope that makes sense. So now let's start. We're going to derive the first derivative. So the first derivative is given to be negative 3t squared plus 18t. And then I need to do the derivative of the derivative. So derivative of the derivative is going to be negative 6t plus 18. I'm sure we know how to derive, ladies and gentlemen, from there to there. And we need to set this to 0. Minus 6t plus 18 is equals to 0, because we're looking for maximum speed. That is when the acceleration is 0. Then we can see that, therefore, the value of t here will be 3 hours. All right? And then, now, which means this guy is going to reach the maximum speed after 3 hours. To get that maximum speed, we need to substitute the time into the speed formula. Remember, the speed formula is s at t is negative 3t squared plus 18t. Now we're looking for s prime at 3. That is the maximum speed. Remember, this is speed, but at t3 we get the maximum speed. Okay, so I'm substituting the 3. And that gives us 27 kilometers per hour. I'm sure, ladies and gentlemen, you can see how consistent I am with my units of measurement. That is very important. So the cyclist hits a top speed at 27 kilometers per hour at 3 hours into the ride. Perfect. Now let's go to 10.2. Let's see what they want us to calculate on 10.2. Calculate the distance between towns P and T. Okay, let's go and analyze that. We need the distance between these two towns that this guy is traveling. Okay, now let's find when the cyclist stop. I need to find out after how long will the cyclist stop. So obviously we need to set the speed to what? To 0. Because it's gonna stop now. All right, so you set the acceleration to 0 if you are calculating maximum speed. But if you need where he has stopped, you make the speed 0. So we have negative 3t squared plus 18t equals to 0. Okay? And then we factor out minus 3t, which leaves us with t minus 6 is equals to 0. And then using the zero product principle, minus 3t would be equals to 0, or t minus 6 would be equals to 0. So t will be equals to 0, or t would be equals to 6. And we can see that this is when he starts, right? When he starts moving, obviously he was stationary. So we can see that we're going to take t equals to 6 hours, which means this guy is going to travel for 6 hours. Perfect. Okay. So this guy traveled for 6 hours. Now we need to do this. To get the distance, we're going to do what I call the reverse. The reverse, right? Remember, usually, because you can see that my speed is in this form. It's in this form. A t squared plus b t. All right. So you can see it's parabolic. So we are now going to go back to distance. Distance means it was cubic. So which means s at t, which is distance, was a t to the power 3. Because when I differentiate, I'm going to get to the power 2, which is the what? The distance. Plus, yeah, this was a little bit high order question. I won't lie. And then b t squared plus c. I'll show you why I stop here. I would have said ct, but I'm not going to say that because remember, the derivative of s at t has 2 terms, which means s at t can have a maximum of 3 terms. It can have 2 or 3, and the third term must be a constant, so that is going to disappear when we differentiate. I'm sure I'm making sense, ladies and gentlemen. Now, s derive of t, which is basically our what? Our speed is 3at squared plus 2bt. Do you see it? And then we're going to have s at t, aligned to the original one, which is minus 3t squared plus 18t. Yeah? You can easily see that this guy will go together and those guys will go together. So 3a will be minus 3, or 2b would be 18. And then we can see that a would be minus 1, or b would be 9. So substituting this back, we can see that, okay, the distance traveled can be modeled by negative t cubed plus 9t squared plus c. I'm just substituting this back to here. All right. And then from there, we know that at t equals to 0, s at 0 will be equals to 0. All right. We know that when t is 0, the speed is also 0. Right. So which means s at 0 will be 0. Therefore, we can see that c must be 0. Remember, c is basically our y-intercept. So when x is 0, the y is also 0, because these two parts will be 0. I'm sure it makes sense, ladies and gents. So therefore, s at t would be minus t cubed plus 9t squared. All right. Now s at 6, we want to know how much he had traveled after 6 hours. So I'm substituting 6. And then putting that on your calculator should give you 108 kilometers. So the cyclist traveled 108 kilometers between town P and T. No guesswork, pure calculus power. Right. Now I need us to have a quick recap. Why acceleration 0 at maximum speed? Remember, legends, maximum speed happens when speed stops increasing. That means acceleration is 0. We're not saying speed itself is 0, just that is not changing at that instant. That's why we say the acceleration must be 0. Yeah? We're fine. Eh? Remember this. This is a warning. Trying to find maximum speed without setting acceleration to 0 is like trying to win Idols SA without singing. It ain't just gonna happen, my friend. And that's how you smash speed and distance questions with understanding, not just memorizing steps. Keep practicing with the 2-in-1 maths plug, where maths becomes your bestie. Don't forget to like, subscribe, and remember, maths never sleeps. Tango!